Every time a plane takes off, hundreds of tons of metal rise into the sky like it's nothing. No flapping wings, no magic, just physics. So how does something that heavy actually fly? And more importantly, what keeps it flying safely every single day? At its core, flying comes down to four main forces: lift, weight, thrust, and drag. Weight pulls the airplane down toward the earth. Lift pushes it up. Thrust moves it forward. Drag tries to slow it down. When lift becomes stronger than weight, the airplane rises. When thrust overcomes drag, it keeps moving forward. These forces are always working together, like an invisible balancing act in the sky. The secret isn't that planes ignore gravity. It's that they work with physics so precisely that gravity becomes just another force to manage. The real star of flight is the wing. Airplane wings are not flat like a board. They are curved on top and flatter underneath. This shape is called an airfoil. When the plane moves forward, air splits around the wing. The air moving over the curved top travels faster than the air below. Faster air creates lower pressure. Higher pressure under the wing pushes upward. That upward push is lift. The wing isn't fighting the air, it's shaping the air. And that shaping creates the force that carries the plane into the sky. But wings alone are not enough. The airplane needs speed. That is where engines come in. Engines create thrust by pushing air backward. According to basic physics, pushing air backward pushes the airplane forward. As speed increases, more air flows over the wings. More airflow means more lift. That is why planes need a runway. They must reach a certain speed before lift becomes strong enough to overcome weight. Without enough speed, even the best designed wings cannot create flight. Speed turns the wing's design into real lifting power. You might wonder why planes do not just fall when engines stop. The answer is simple. Airplanes are designed to glide. Even without engine power, air continues flowing over the wings as the plane moves forward. This still creates lift. The aircraft slowly descends instead of dropping straight down. Pilots are trained for this exact situation. Modern aircraft can glide long distances safely. Flight is not fragile. It is carefully engineered with backup systems, training, and aerodynamic design that allow planes to remain stable even in challenging situations. Control is another important part of flight. Airplanes move in three directions: up and down, left and right, and tilting side to side. Special control surfaces on the wings and tail manage this. Flaps and elevators adjust pitch. Ailerons control roll. The rudder controls yaw. Small movements of these surfaces change airflow and shift balance. Pilots are constantly making tiny corrections. It may feel smooth inside the cabin, but behind the scenes, physics is being adjusted every second. Flight is not just about lifting off. It is about staying balanced. Now let's talk about how flying affects passengers. During takeoff, acceleration pushes you back into your seat. During landing, you feel forward pressure. These sensations come from changes in speed and direction. Turbulence, which feels like shaking, is simply uneven air currents. It is uncomfortable but rarely dangerous. Aircraft are built to handle far stronger forces than typical turbulence. Understanding this reduces fear. The sky is not random chaos. It is layers of moving air. Planes are designed to travel through those layers safely and predictably. Safety in aviation is not accidental. Every aircraft goes through strict inspections before and after flights. Engines, wings, tires, electronics, and fuel systems are checked carefully. Pilots train in simulators for emergencies that most passengers will never experience. There are multiple backup systems for critical functions. Even if one system fails, another takes over. Aviation operates on layers of protection. This is why commercial air travel remains one of the safest forms of transportation in the world. Safety is built into the design, not left to luck. Weather plays a big role in flight, but modern technology helps manage it. Radar systems detect storms. Pilots adjust routes to avoid dangerous conditions. De-icing systems prevent ice from forming on wings. Ice can disturb airflow and reduce lift, so preventing it is essential. Airports and air traffic controllers coordinate carefully to maintain safe spacing between planes. Flying may look simple from the ground, But in reality, it is supported by a global network of monitoring systems that constantly reduce risk and improve safety. To prevent problems in aviation, preparation is everything. Maintenance schedules are strict. Fuel calculations are precise. Weight distribution is carefully balanced before takeoff. Even passenger luggage is accounted for in flight planning. Prevention also includes communication between pilots and air traffic control. Clear communication reduces misunderstandings and ensures safe navigation. Aviation does not wait for problems to appear. It anticipates them. Every flight is planned with detailed procedures that aim to eliminate risk before the plane ever leaves the runway. In the end, airplanes fly not because they defy gravity, but because they understand it. Wings shape air. Engines create motion. Physics does the rest. What seems impossible from the ground becomes logical in the sky. The next time you see a plane rising above the clouds, remember this: it is not magic. It is engineering, training, and science working together in perfect balance. And that balance is what keeps millions of people traveling safely across the world every single day.